right, so on page 54, section P5, we're looking at solving inequalities algebraically and graphically. When you solve an inequality, you're going to solve it exactly like you would an equality, with the exception of one thing. What is the one thing that you have to do differently when you're solving an inequality than when you're solving an equality? One key thing I have to do differently. Yes? Yes, if you multiply or divide by a negative, you must reverse your inequality sign. So that's the key difference. So I'm going to start off as if this said equal to. All right, if that said equal to, what would you do?
Solve for x.
Solve for x, yes. So how am I going to do that? All right, so let's add 7 to both sides. What else?
Minus 3x.
Subtract 3x. All right, then what? Divide by 2. Do I need to reverse my inequality? No. It's only if you multiply or divide by a negative, not if you just multiply or divide. So there's our answer. X is greater than 8. Now that's the way that you would have written it in Algebra 2. But when you get into advanced mathematics and college level mathematics, they're going to ask you to write your answer in a different form using something called interval notation. All right? A couple of things about interval notation. If you're working with less than or greater than, you used an open dot in Algebra 2. The equivalent of that in interval notation is a parenthesis. And if you had less than equal to or greater than equal to where you used a closed dot, the equivalent for that would be a bracket. So here's what I'm going to do with that answer. In interval notation, it's almost going to look like an ordered pair. You're going to have your lowest value on the left-hand side and your highest value on the right-hand side. So here's what I mean. For this one, if I'm saying x is greater than 8, the lowest value that this can be is 8. Now, I know we're not actually equal to 8. If you were graphing this in Algebra 2, you would have put like an open dot on 8, right? Meaning the graph could come right up to it, like 8.00001. So that's kind of like a boundary marker for us at 8. And then if it's x is greater than 8, then it's getting larger and larger without bound. What do we call that? Infinity, right. So I literally write infinity for my highest value on that right-hand side. Now, we mentioned that if you had less than or greater than, which we did here, we had greater than, that you would use a parenthesis. And so that's what I'm going to put with my 8, and that's what I'm going to put with my infinity. And that would be my interval notation. That's the way that in interval notation I write the solution, x is greater than 8. Okay, why do they have me learn this whole new notation, new way of writing this? Because interval notation very closely mimics what your graph is going to look like. If I were to graph this, when we did this in Algebra 2, we would have put an open dot on 8. So what we're going to do is we're going to put a parenthesis there instead, because again, the open dot and the parenthesis are the same. And then I'm going to shade all the values that are greater than 8, so I'm going to shade off to the right. And so that interval notation will look like my graph. And I'll get to the point after I've used interval notation for a while that when I look at the interval notation, I can envision that graph and picture it, and that's the advantage of it. Now, I'm only going to use a bracket when I can say that I am equal to something. Can you be equal to infinity? No, infinity is not even a number, right? It's a symbol that represents the concept of something getting infinitely larger without bound. I can't walk up and put my finger on infinity. I can't be equal to it. So for that reason, it does not matter what sign I have. Any time in an interval that I have infinity or negative infinity, I will always put a parenthesis with it, without exception, always. All right? Look at the next one. I've got 1 minus 3x over 2 is greater than or equal to x minus 4. I'm going to treat that just as if it said equal to. So what would you do first if it was an equation? Multiply by 2. Let's get rid of those fractions. All right, then I'm going to get all of my x's over on the left-hand side. So I'm going to subtract 2x from both sides. And then I'll move all my constants to the right-hand side, so I'll subtract that 2 over to the right. Then what? And when I divide by -5 at the same time, yes, I'm going to reverse my inequality sign. Because when I multiply or divide by negative, I have to reverse my inequality sign. All right, so let's think about the interval notation for this guy. X is less than or equal to 2. Where's the 2 going to go, on the right or on the left? Is it the highest value or the lowest value? All right, so it's going to go on the right-hand side because it's our highest value. And if we're saying all the values less than that, where's that going to? Negative infinity. Good. So negative infinity will be our lowest value. Now, because this was less than or equal to, then I'm going to put brackets with both of them, right? No, I'm going to put a bracket with the 2. But what about the infinity? Always a parenthesis with positive or negative infinity. All right, so if I were to graph that, whereas I would have put a closed dot on the positive 2, I'm going to put the bracket on positive 2. And then typically I would have shaded off to negative infinity. I'll still do that same thing. All right, example 3, they give us a double inequality. It is exactly what it sounds like. It is 2 inequalities in one. As a matter of fact, if you want to break it apart into 2 separate pieces and work it as 2 separate problems, and then when you're done, just smash it back together again, you're welcome to do that. Or you're welcome to work with it in its joined together form. Either way you want to go. Just so that it was easier for us to see, I did go ahead and break this into the 2 separate pieces. And I'm going to write and in between here just to remind me, hey, when I'm done, I got to put these back together again. X has to be, it has to fit the criteria over here and at the same time the criteria over here. Okay, so let's start with this guy. If I were trying to get X by itself, what would you do? Add 1. So we'll add 1 here. And same story, add 1 over here. Then what? Divide by 6. And of course we would reduce any fractions, so 2 divided by 6 would give us the 1/3, and 4 divided by 6 would give us the 2/3. So again, I chose to break this into 2 separate pieces. So when I'm done, if I do that, I do have to put those 2 separate pieces back together again as one combined inequality. So I can just say negative 1/3 is less than or equal to X, and at the same time less than 2/3. So negative 1/3 is less than or equal to X is less than 2/3. All right, interval notation for that. What is my lowest value? Negative 1/3. What is my highest value? Positive 2/3. What goes with the negative 1/3? Parenthesis or bracket? How about with the 2/3? Good. It was equal to over here, so I needed a bracket. It was not equal to over here, so I needed a parenthesis. And again, if I were to graph that, I would have a bracket on the negative 1/3, a parenthesis on the positive 2/3, and I'm shading in between. And here again is a great example for us to be able to see how the interval notation so perfectly mimics what the graph would look like. And that's the reason why we like that notation. All right, then over on page 57, they talk to us about inequalities that have absolute value in them. What is absolute? Okay. What's absolute in your life? You have anything in your life that is absolute?
Christmas.
I like that. Not absolute for everybody, though. Death and taxes, right? It's like all that we can count on. What is absolute in your life? I'd like to think that there are some people in your life that are absolute. You know, hopefully you have some friends that are always there for you, that you can count on, that are a rock for you. Hopefully there's somebody in your family or a guardian or somebody that you can always count on, that's there for you, that you can depend on. As much as I would like to be the perfect friend and the perfect mother, I'm human and I'm not going to be. And I fail my friends and I definitely fail my children. So anybody that puts their hope in me, that I'm going to be their absolute, their rock, their stability, at some point I'm going to disappoint them. So to me, the awesome thing is that we do have an absolute in our life that we can always depend on, that never fails us, that is always there for us, even if you're on the opposite side of the globe from your parents or your friends or whatever, he's still there with you. And so I love the fact that God can be an absolute in our life. When we talk about trying to define black and white, right and wrong, what is absolute truth? In John 14:6, Jesus said, I am the way, I am the truth, and the life. And there is no way to get to God except through me. So when we're looking at the most important decision that we'll ever make about our eternal security, Jesus said, I'm it. I'm the way. I'm the truth. I'm your absolute. You can count on me. You can depend on me. A little while back, my pastor did a sermon where he was talking about some of the attributes of God and how we can depend on him. And to kind of help this stand out to us, he said, what if the opposite were true? What if you couldn't depend on God? And he went through and he took Psalm 23 and he completely rewrote it. You know, when you're having a hard time, that's for a lot of people, that's one of the first chapters that they would go to. It's the, the Lord is my shepherd, and it's very comforting. And he said, what if it read like this? The Lord is not my shepherd, so I'll always be in need. He doesn't walk beside me when I walk through the valley of the shadow of death. When I am facing my biggest fears and obstacles, he's gone. He leaves me. He doesn't go there with me. He doesn't prepare the way before me. He doesn't guide me. He doesn't direct me. He doesn't protect me. I am completely alone. I'm desolate. I'm in need. I have nothing. And it really just smacked me in the face about how much I take for granted that one absolute truth in my life, and what my life would be like and how different my world would be if God was not our absolute, and if he wasn't always there for us, and if we couldn't depend on him. So every time I look at absolute value, I'm reminded of the very few things in my life that are absolute, but so thankful for a God that is, that I can always count on. All right, so two different types of absolute value inequalities, and we have different formulas for each of them. The first is a conjunction, and the second is a disjunction. Now, here's how I can tell which one is which. When I have the absolute value on the left-hand side, and I have a less than symbol, that's a conjunction. When I have the absolute value on the left-hand side and I have a greater than symbol, that's a disjunction. The reason I stress that whole left-hand side thing is because you and I both know that we can turn inequalities around. Like if you had the absolute value of x is less than 2, that's the same thing as 2 is greater than the absolute value of x, right? Those are identical statements. Little n towards the x, big N towards the 2. Little n towards the x, big N towards the 2. But here it looks like a conjunction in the top one, and in the bottom one it looks like a disjunction. So if I want to look at it and say if it's less than it's a conjunction and if it's greater than it's a disjunction, I have to make sure that absolute value is on the left-hand side. Also, if you'll notice, see how this one looks like a C right there? So that's an easy way to remember. That's the conjunction. And if you drew a line right here, a straight line right here, that would make like a capital D. So that's an easy way to remember that's a disjunction. A conjunction is an and statement. A disjunction is an or statement. And so here's the formula for our conjunction. Negative a is less than x is less than a. And here's our formula for a disjunction. Negative a is greater than x, or x is greater than a. I have a horrible time memorizing. I cannot memorize formulas to save my life. And so that's why I'm always sharing with you like the reasons behind or where the formulas come from, so it helps us remember them, or some cool little mnemonic device that you can use to help you remember it, because I struggle with that myself. And I had a really hard time with these formulas for absolute value when I was in high school. And so I was sitting at church one night after church was over. I was sitting there waiting for my family, and I was working on my math homework. And there was a gentleman in our church that worked for the Corps of Engineers, and he came over and he's like, oh, pre-calculus. You know, he's all excited because I'm doing advanced math. And he's like, what are you working on? And I'm like, oh, I cannot do these stupid inequalities to save my life. And he was like, oh, let me show you this cool little trick to go along with those. Then you don't have to know the formulas. And I was like, oh, please. So there's nothing mathematically sound about this. It's just a little mnemonic device, just a little trick that's an easy way for you to be able to do all of your absolute value inequalities the exact same way, okay? So here's what my friend the engineer said. I mean, engineers, it's their job to take complicated things and make them easy, right? Make solutions. So here's what he said. Anytime you're working with an absolute value inequality, doesn't matter if it's conjunction, disjunction, whatever, what you're going to do is copy exactly what you had, x is less than a, without the absolute value. Then copy copy the same sign on the opposite side. So we had less than, we'll copy less than over here. Copy the opposite number. I had positive a, so I'll copy negative a. So one more time. Copy exactly what you had without the absolute value. Copy that same sign on the other side. And then copy the opposite number. How is that any easier than memorizing the formula? Because I get to do all of them the same way instead of having to memorize two different ways to do two different things. Let me show you. Over here, I'm going to copy exactly what I have without the absolute value. I'm going to copy that same sign, and I'm going to copy the opposite of that number. The only thing that I have to do at that point is I look at this and go, that's a conjunction, that's an and statement, I leave that one together. And sure enough, there it is. Negative a is less than x is less than a. That's the same thing we got right there. Over here, I'm going to look at this one and go, that's a disjunction, that's an or statement, I just have to break this apart with an or in between. So negative a is greater than x, or x is greater than a. So that's what I did, and sure enough, that's that exact formula right there. So when I see an absolute value inequality, I don't memorize a formula. It doesn't matter if it's a conjunction or a disjunction. When I look at it, I copy exactly what I had without the absolute value. I copy that same sign over on the other side, and I copy the opposite of that number. Is this one a conjunction or a disjunction? Conjunction, so I can leave it all together and solve it just like we were doing our double inequality up above, right? I could go through and just add 5 to both sides, and there's my answer. 3 is less than x is less than 7. When it's an and statement, I leave it all together. I don't have to break it into two separate pieces and say and in between. When I write it this way, I'm saying 3 is less than x, and at the same time x is less than 7. If I wanted interval notation for that, as we've been doing today, I could give that. If I wanted a graph for it, I could give that, whatever they want me to find. Look at another one of those. Over here, we've got the absolute value of x minus 5 is greater than 2. So for the absolute value, I'm going to copy exactly what I have without the absolute value. Copy that same sign on the other side. Copy the opposite number. Is this a conjunction or a disjunction? Disjunction. So this one I'm going to have to break apart into two separate pieces. So again, going back to like we were doing before, where sometimes we have 2 in 1, like a double. All right, so to solve this guy, what do I need to do?
Plus 5.
Add 5 to both sides, and then same story over here, right? Add 5 to both sides. So my solution is 3 is greater than x, or x is greater than 7. Two separate answers. If I'm getting two separate answers, by the way, if you miss the fact that this is a disjunction, like you go all the way through this problem and you get down to the bottom, you'll catch it at the bottom if you just think about it for a second. Because if I had written this as an and statement where I had left this all together, then what this would say is 3 is greater than x, and at the same time x is greater than 7. Okay, how can 3 be bigger than x? That means that x has to be like 2, 1, 0, something like that, right? And at the same time, x has to be bigger than 7. How can it be smaller than 3 and bigger than 7 at the same time? That's not possible. So if you'll use some common sense when you get down to that bottom, you'll catch it if by chance you forget to put that or statement in there. Okay? So I've got two separate answers. I literally have to write that with two separate interval notations. Because remember, when you graph an or statement, you have one piece of the graph going off one direction and one piece of the graph going off the other direction, right? So if you have two separate pieces on the graph, you have two separate solutions, you're going to have two separate interval notations. In between those two separate interval notations that we've listed there, notice there's like a U in between them. That's that union symbol from geometry. where union just means unite, so it's basically taking the two pieces of our answer and uniting them to altogether be our answer. Okay? Mathematicians are some of the laziest people on the face of the earth. I will have multiple proofs of that during the course of the year, but here is the first of many examples. Let me explain this to you before you write it down, and then I'll give opportunity for you to write this down. On the homework, there's one problem that I'm not sure you're going to understand what they want you to do because they tried to take a shortcut. On number 25, it says y is equal to 2x minus 3. For A, we want you to make y greater than or equal to 1. What they literally want you to do, since y is 2x minus 3, they want you to say 2x minus 3 is greater than or equal to 1. Why they didn't just write it that way, I don't know. They were trying to take a shortcut. Same story over here for B. They say, now let y be less than or equal to 0. Since y was 2x minus 3, they just want you to do 2x minus 3 is less than or equal to 0. So I just wanted to make sure you understood what they were asking you there and it didn't confuse you. Okay? And so here's our homework on pages 63 and 64.